Assalamu alaikum dear students. So I'd like to go over and do one more recording on the software that we do. So what I'm gonna do, I'll go to any of the sections, and in the content go to class activities, chapter 11. And in chapter 11 I already put a video, so this is the time for the second video. So these are the set of questions which we put for the activity 2, and this is the some guides on taking some problems from here and being solved here. So I click on this. So this is the guide that you can find, and there is a solution being posted there while solving them. Okay, so what we're going to do, we'll look into one by one. So the principal topic in here is the integration by substitution. As you can see that we have reached to the point where we have complex expressions such as this 3x minus 4 to the power of 5. Now opening this is not possible because it's not square power. So the idea is here that whatever you see, the idea is here that you solve this integration which does not contain any limit. You are basically summing this expression using the substitution. So what is the core principle of substitution? Substitution changes from problem to problem, but in here when you have an expression and has a compound power, so in this case what we take is the expression itself as a u. So this is what we gonna substitute as u. Now I took the simple derivative, so du upon dx is du upon dx of this u, and the derivative is 3. So you can find du upon dx is 3. And similarly, if I move the dx there, it's gonna be du is equal to 3 dx. Alternatively, if I bring the 3 here, so it will come in the bottom, and this will be 3 du upon 3. Now notice that this is your expression, right? Actually the problem is this 3x minus 4. So this is the expression. Now you substitute in here u, and dx is replaced by du upon 3, as you can see from here. So you can see the whole integral from x goes to the u. Now you can see that it's a simply a integral that you can take the 3 out, which is a constant. It is basically integral u to the power 5 du. Now notice here we can use the power rule in here, which is u to the power any n du is equals to u to the power n plus 1 divided by n plus 1, where n cannot be negative 1. So here there's a some typo, I missed that negative 1, so it should be negative 1. Now what I'm gonna do here, if you look at this, it's 5, right? N is 5 in here, you can see it's n5. So in this case the answer is u, which we apply the rule, and u to the power 5 plus 1 divided by 5 plus 1, and notice here that 1 upon 3 was a constant, stays there. The moment the integration sign is off, the c comes, which is the constant of integration, and you can sum the powers. It will be 6 and divide by 6, so this 3 times 3 makes 18, u to the power 6 plus c. Now if you recall that our problem was in x, not in u, right? U is used to solve the problem as a new variable. So what we know our relationship between u and x, so we just replace the u in here by this relationship, which is the u contains 4, 3x minus 4, and this is an answer to this question. Now the second question is relatively different. How much is the power? The power is half. This is a compound expression and the whole power is half. So again I do the same analogy. I just take this variable as a u, so 9x minus 3 is u. If we take the derivative, it's gonna be, in this case it will be negative 6x, right? And then you can say negative 6x, and you can bring the x dx in here, so it will be negative 6x dx, which is du. And you can look at this, it becomes such as dx x dx is one side, so you can see it here, and the 6 goes in the bottom, moved here, and with the negative sign, so it becomes du upon 6 with the negative sign, so you can see it here. So this is the why I did that, because I can see that there is some arrangement that I can do. For example, look at this integral, which is the same 4x radical sign of 9 minus 3x squared dx. Now I can also write it here 9x minus 3x with the root sign and 4x before, just move here. So it's a commutative. So either write a and b or write b and a. So this is the same. Now notice here that this guy, which is x dx, is what? Du upon 6 negative sign, right? So I replace it. And this is the person we assumed as 9 minus 3x squared, which is u. So I write it here u with the root sign. And now the 4 is left over. So this is 4. Now you can notice that the 4 and 3 cancel each other and become 2 upon 3. And you can see that negative sign has been taken out. Now how much is the power? Half. Excuse me. So we again apply the power rule. So if you apply the power rule, u to the un plus 1 divided by n plus 1. So this is half plus 1, half plus 1. You can see 3 upon 2 and then 3 upon 2. You can notice that this is in the bottom. So this fraction you can remove by just reciprocating this. So it will be 2 upon 3. And you can notice that the 2 and 2 makes 4 and then 9 in here. So it should be 4 upon 9. So this 4 upon 9 has been missed, but you can fix it up. And this is how you can also write it here as and now notice here that the u is how much? U is, in our supposition, u is 9 minus 3x squared. So in this case, what you can do, you can write it, return the value of u as 9 minus 3x squared. So this would be an answer to this question. Now notice here, this is the next integral, but here who is the variable? If you notice that the who is variable, who is written after d sign, which is y. So in this case, the y is variable, not the x. But again, we follow the same logic. Whatever this inside the power sign, which is the whole power of half, we suppose as u. Now if we take the derivative, now notice that the derivative of y with respect to this variable is 1, and hence du is equals to dy, because y can come here, 1 times dy is dy. Now you can write it here 6 times root 5, root 5th root of y plus 1 dy is 6 times y to the power of 1 upon 5 dy, which is written as u and du, and with the power of 1 upon 5. And again you can write it back as the power rule. Again I use the power rule. So this is 1 upon 5 plus 1, 1 upon 5 plus 1. Now notice that this 6 upon 5, which is 1 upon 5 upon 1, would be 6 upon 5, and similarly 6 upon 5. You can reciprocate this, it becomes 5 upon 6, and this 6 cancels with this, and you get 5. So this is the answer, but the answer is incomplete because the problem was given to you in y. The answer should be in y. So what we're going to do, we replace the u, which we use for us, and replace the value of u with y plus 1. So this is the one that we have replaced for y plus 1. And this is an answer to this question. Now we reach to a new domain of the integrals, which is called the e. As I mentioned, as in calculus, if the variable is in power, the only time it can be solved is when the base is e. So this is the new formula that we have, similar to differential. The integral of e to the power u du is e to the power u. So the same is the answer. Now here, what is the trick? The trick is very simple. Whenever you have an integral with the e, suppose the power of e as u. It's very simple trick in here. So what we do, we again substitute, and substitute what? The power of e. So in this case, negative 2x is u. If we take the derivative of this, du upon dx, d upon dx of negative 2x is negative 2. And we manipulate, so if we bring this guy in here and the 2 in bottom, so it will be dx is equals to u upon negative 2. Now notice here that this is the expression, right? E to the power integral e 2x dx. So 2x is basically negative sign is u, as we supposed in here, right? So in this case, this is u. And now the dx is how much? If we replace the dx by du, notice here that when you're moving from x to u, everything should go from x to u. So dx should also be replaced by du. So this is what we are replacing. So dx is replaced by du upon 2. And in this case, it is simply, you can see that integral eu du, which is the case, and the negative 1 upon half is taken out because it's a constant. Now we recall that this is the formula that we have, right? So apply the formula, integral of e to the power u du is the e to the power u du plus c. So this is an answer to this question, very simple. But here we call that the u is negative 2x, and hence what we do, we replace the u by negative 2x. And this is the solution to the problem. Very similar question, e to the power 7x, 7 minus 2x. What we're gonna do, we have the same formula in the mind, but the logic is what? We take the power of e as u. So this is the first key step. We take the derivative, you can see that it will be negative 2. And the du will be, if we remove the dx in there, it will be dx du upon 2, and the 2 comes in bottom, so that makes negative 2. So this is du upon 2 with negative sign is equals to dx. Now notice here how we are replacing. This is our e to the power 7 minus x, 7 minus 2x. So 7 minus 2x is u, right? So I replace this 7 minus 2, e to the power 7 minus 2x is the power with u. And what about dx? I replace the power dx by du upon 2 with negative sign. And hence everything in x moves to u. And you can see now the expression is very simplified. Now we again use the power rule, formula for the exponential integration. And if you do this, what we're gonna do, we have the same integral, right? We already transformed this, but using the integration formula, the integral of e to the power u is the same expression with the addition of constant of integration. But we recall that the u is 7 negative 2x, so what we do, we replace the u by 7 negative 2x. And this is the answer to this question. Now this integral looks a little bit longer, but actually it's the same logic. And you can see that there are 3 parts of the integral. So we also follow the same logic that we break the integral into 3 parts. First part, second part, and the third part. So you can see that the 3 integration sign in here, right? And you can do this actually. For sum it, you need to break it. So what we do, we first consider the first part, and we do the same logic, right? Take the power of u as u, and then we take the derivative of du upon dx, so it will be 2, and du would be how much? 2 dx, right? But you can also bring the 2 in the bottom, it becomes du upon 2 is equals to dx. Now e to the power integral e to the power 2x dx would be e to the power u, and dx would be what? You can see it here, du upon 2. So what I see that the half is taken out, and e to the integral e to the power u du is we having a formula for this, which is how much? E to the power u plus c. So what we do, we write it here, e to the power u plus c. Now what we can do, we notice that the u is a substitution for us, which is this relationship 2x. So what we do, we replace the u by 2x, and this is an answer. Now what we have in here, that the next part we have the e to the power negative sign in here. So this negative is missed, but actually this is the integral for you. You can obtain the same way as you obtain for the question number 1. So we had the same answer. You can look at this, how you obtained that. So basically second part is the same. Now the third part in here, or the last part, is this one. Notice here that e does not contain any variable, and hence very simple answer would be that the e is no longer a variable. The only variable is dx, and hence you know that the integral and differential, they cancel each other, so answer would be this number. Now what you can do, you can sum this together, and once you sum this together, since the integration is complete, don't forget to add this integration sign, which is the constant of integration. Now the last another question is that when the variable is power but the base is not e, which is very unusual, right? But what you can do, we can take the advantage of this formula. We say that the a is a variable, any variable, and b is another constant or any variable. It can be any commodity. So the answer is that the e and the ln, which is the log and the exponent, they are opposite to each other. So basically they e and ln cancel each other. So this is as if the expression is made to 1, 0. And hence, but we can take the advantage of the log, so this power becomes the base, so e to the power b ln a. Now notice that this is our expression, 4 s to the power s plus 1, right? So here, who is your a? A is 4, right? Okay, who is your b? S plus 1. And hence what I can write it here, e to the power, okay, s plus 1 ln 4 because of this relationship that we got in here. So this is your b, this is your a, and then you can do the integration of this. Now what is the trick that we studied, that whatever the power of e, we assume this as u. So this is what we have assumed in here, right? Now what we do, we differentiate with respect to s. Now notice that this is the only variable, so in this case this is a constant, though although it's a ln, it's a constant, so only variable is this one, s plus 1. You take the derivative, you get 1, because derivative of s with respect to s is 1 and derivative of 1 with respect to s is 0. Now what we do, we just bring the s in here from the bottom to here, the other side, it becomes the ln 4 ds. But you can also write it here, du upon ln 4 is equals to ds. Now this is your expression, right? This is what my expression was, right? I continue with this. This was my expression. I continue with this, right? This is my expression. Now I have already assumed that this is u, so this is u, and the ds is how much after this relationship? ds is equals to du upon 4 ln. So this is the value, du upon 4 ln. What I can see that ln 4 is the constant taken out, so this is, now you can see this replaced with very simplified expression that we already had, ln integral e to the power u du. What we can do, we know this formula, right? So we replace this e to the power u plus integral with this, so this is the answer. But don't forget that you have u is, your problem is in s, you have to replace u with s. So this is what you do, you replace the u with respect to this s, and that's it, this is the answer. Now similarly you can solve this problem, which is very similar nature. I'll skip that because the explanation is very similar, and I believe that we have done very similar problem. So this is the very similar logic that we make them. First of all, power expression as in within the e expression, and this will be the variable, and you suppose the power of e as u, take the derivatives and transform the derivatives like this, and hence you do what, you replace this with the u, and you using the formula you can also substitute and you get the answer back. Now here we come to the new class of the integral. Notice here, what is the power of u? The power of u is -1, right? And I told you the power rule works for all powers except -1 power. So in this case, if you have -1 power, which is like this, the answer is ln u. And similarly, if you have 1 upon x dx, the answer would be ln x. So what you do in this case, that whatever you see in the bottom, which is the expression, you suppose this as u. So I did that, and we take the derivative of that. So this du upon x is 2, and hence du is equals to 2 dx. So you can see it, right? Dx comes in here, but you can also write it here by bringing the 2 bottom in here in the du. Dx is equals to u upon 2. Now this integral which we had, this is our integral, right? This is our integral, this is u, so I replace it, right? And the dx is how much? Dx du upon 2, and hence the half is taken away, so 1 upon 2, 1 upon u du, right? Now you can see that this is particular expression that we have, and this is the formula, right? So in this case, 1 upon half integral 1 upon u du would be ln u plus c. Notice here u is usually observed to be positive. This u should be always positive. Now what we do, we replace that u with 2x minus 1. So this is replaced, u is replaced by 2x minus 1, and hence this is an answer to this question. It's a very similar problem. The only new thing is that in the bottom you have different number and on top you have a constant. So similarly, since the power is of this expression is 1, but in bottom, so it will be -1. So for this reason you suppose this as u, and if you suppose this as a u, it will be 7, right? Now du upon dx is equal to 7, you can write it here du 7x, 7 dx, and you can also write in different way, dx is equal to du upon 7. So this is one of the possibilities. Now notice here that this is your integral, right? Now I substitute this by u, so this is u, and dx is how much? Dx is du upon 7. And notice that the 4 is a constant, so taken out, okay? And then you can write it here as 1 upon u du, and this is basically an integral. You can apply the formula, and if you apply, it's gonna be ln u. So this is the expression that you got, but notice that you have to replace the u by 9 plus 7x. So in this case, the u is replaced by 9 plus 7x. Now this is the last question, although it's a very tricky question, and I told you that in many of the time, sometimes you have to think a little bit out of the box to find out what could be the right substitution. So what I believe that this is the right substitution, and I solved this and I found that this is correct. So this is what we do. We suppose this as a u. Okay, and if we suppose this as a u, so the integral of the ln is 1 upon this expression, so it is x square minus plus 3x plus 11, and then you take the derivative of the expression, which is x square plus 3x upon plus 11, and hence the answer is 2x plus 3. So this is the expression that you got, right? Similarly, du upon dx is equals to this number, right? But I can bring the dx in here from here, and this is the du is equals to this number. Now notice here, what is the expression you have? You have ln x square plus 3x plus 11, right? Which is your, how much? U. This is my u, right? So this is the u. And what about this expression? If I want to write it here, what is that expression? This is du actually. So what I can write it here simply u du. And in this case, it will be again the power rule apply. So in this case, the answer is how much? That this integral altogether is integral u du, and hence I apply the power rule, u 1 plus 1 divided by 1 plus 1, which is u square upon 2 plus c. Notice here, what is your u? U is your ln x square plus 3x plus 11. So in this case, this integral is ln square. So notice here, because of the square, right? U square, u is how much? Ln. So ln square 2x plus 3x plus 11 upon 2 plus c. So this is the answer to this question. There were some issues that I did by not knowingly. For instance, this if you look at this, that the 4 was on top, so it cannot come in the bottom, so it will be 4 upon 7, not 28. So this, please mark it out in your solution. And one other place I did a mistake, I'd like to notify you. I believe that's correct, but one of the mistake which I have realized after doing some analysis is this one. So kindly fix that. Just the number which you have to fix, otherwise all is correct. So let me notify you which one is this. Kindly notice that this is correct. And this is the issue that we had come up. So it will be 2 upon 3, right? And 2 upon 3. So they will not cancel. So it will be 4 upon 9. So it should be 4 upon 9 in here. So the answer should be 4 upon 9 in here. And this should be the mistake, best to my knowledge, in this. So I stop here, and I hope that you will watch this video and then will generate learning to you. Thank you very much.